Hello, today we will discuss about the application of integral to find the volume. Okay, so we will start with the first method. This is this method. We have a curve y equal fx, line x equal a, and also line x equal b, and we get a region D bounded by this curve y, this line x-axis, and also this line, and we can write D with this notation: all pairs of x and y where x between a and b and y between 0 and fx. Okay, we will use integral to find the volume of solid generated by revolving this region D about x-axis. Okay, and when we use this method, we will find the volume of region between the curve and the x-axis, and the formula is volume equal V times integral from a to b fx square dx. A similar way is similar formula we get when we revolve this curve about y-axis and we change x by y. This is fy and dy, and the bound is in y. Okay, we will discuss an example for this method. Find the volume of the solid generated by revolving the region R bounded by curve y equal square root x, x-axis from x equal 0 to x equal 4 about x-axis. Okay, first we will sketch the graph. Okay, like this. This is for the curve y equal square root x. This is x-axis, and from x equal 0 this line, and to x equal 4 this line. Okay, and the region D is this region. Okay, we will revolve it by x-axis. Okay, for the bound we have 0 to 4, and by this method, because this region there is only the curve and also the x-axis, we can directly use this square root x squared, and we will have v times integral from 0 to 4 x dx, and you can continue this. Okay, this is for the example of a question with this method. Okay, next we will introduce the second method. It is cylindrical shell method. Okay, again we have a curve y equal fx, these two lines x equal a and x equal b, and we assume that a is positive, so we have this region D noted by this, and we will revolve it about y-axis. Okay, by the cylindrical method, we have the volume is this. Volume about y-axis equal to v times integral a to b x times fx dx. Okay, so we can still use dx when we revolve it about y-axis. Next, we will explain the difference of those two methods. Okay, again we have the same question. We will find the volume of the solid generated by revolving r bounded by this from x equals 0 to x equals 4 about in this case we revolve about y-axis. Okay. Okay, this is for the curve. It is the same curve with last example, and now we revolve it about y-axis. Okay, by the cylindrical method we can directly use the formula, so we get v oy equal 2p times integral from 0 to 4. This is x times fx, and the fx is square root x dx. Okay, and you can continue it. So how, if we want to use this method to solve this, okay, we can also use this method, but with a little construction. Okay. Okay, this is, in this case we want to use this method. We will revolve it about y-axis, and if we consider again this method is to find the volume between the curve and also the y-axis. So if we use this method directly, we will have the volume of this region revolved by y-axis. Okay, once again, if we use this method directly, we will have the volume of this region revolved by y-axis, and this is not our goals. The goals is to find the volume of this region revolved by y. Okay. Now, if we want to use this method, we must try to make a little trick. Okay. Consider this area. This region. Okay, we can get the volume of this region by find the volume of this region revolved by y-axis first, and then subtract it by the volume of this region revolved by y-axis. And for this region we have integral v times integral from 0 to 2, and this is x equal 4. We have 4 square dy minus v times integral 0 to 2 this curve y equal square root x is equivalent with x equal y square, so we have y square and squared again, and we have y to the power of 4, and then we have the volume of solid generated by revolving this region to y-axis. Okay, you must be careful about the use of this method and also cylindrical shell method. Okay, and you must keep the concept. Okay, now we will discuss about solid of region bounded by more than two curves. Okay, we must find the volume of solid generated by revolving the region R bounded by this curve, and also this line, and about x-axis. Remember again about x-axis. Okay, for the for the sketch of graph, this is the line. This is for y equals square root x. This is for 2 times square root x minus 3, and this the line x plus 2y minus 3 equal to 0. Okay, and we will revolve it about x-axis. Okay, okay, this the region R is this bounded by the green curve, red curve, and also the blue line. Okay, and for the x, we will use this method, and we must break down this region into two parts by the line x equal 3, because from 1 to 3 the line curve is above the blue curve, and from 3 to 4 the red curve is above the green curve. So we must break it into two parts. Okay, and we will find the volume of first part. Again, for the bound is 1 and 3, and red curve is above the blue curve. So for the volume 1 is I'm sorry, this is there is a v in this part, in this space. Integral 1 to 3 square root x square minus half times 3 minus x square, and we get the volume of first part. How about the second part? The bound is 3 and 4. Also the red curve is above the green curve. So the second volume is v times integral 3 to 4 square root x square minus 2 times x square root x minus 3 square. Okay, and we have the volume of first part and also the volume of second part. Then for the total volume, we sum these two volumes. Okay, maybe you can also use the cylindrical shell method by a trick. Okay, thank you.